Alright, I'm going to work this one out, and in fact I'm going to show you two different ways of doing it. One way, of course, immediately you probably think of is the quotient rule, where the quotient rule says take the derivative of the top times leave the bottom alone. So I'm going to leave the bottom alone times the derivative of the top, which would be 3 minus 8, the square root of x, the derivative, remember, is 1 over 2 square roots of x, minus, take the derivative of the bottom, which would be 1, and then leave the top alone, 8 over square root of x, all over the bottom squared. Alright, from here I'm just going to distribute that x, and then of course the negative 1, and then also I'm going to notice, well, 2 will go into 8 4 times, so I will end up with 3x minus 4x over the square root of x, don't lose that part, minus 7 minus 3x plus 8 square roots of x, all over x squared. I notice the 3x's cancel, and here the way my math lab has the answer is just a little weird. So let's kind of look at this. I have minus 4x square root of x minus 7 plus 8 square roots of x. Now remember, all of these are over x squared. So I could just simply put an x squared on the bottom, the denominator of every one of these. So all I did was, this one was kind of weird, is move that to the bottom. Okay, from here, this first one I could cancel, so I end up with a minus 4 over, let's put that x out front, x square roots of x, minus 7 over x squared. This one's going to be a little weird how you do it, but remember, well, first of all, that that's to the 1/2 power, and when you're dividing bases, same bases, you subtract the exponents. So I'm going to actually subtract 1/2 minus 4/2, and that will give me x to the negative 3/2. All right, well, think about that. So I can bring that 3/2 to the bottom. So side note over here, that becomes 8 over x to the 3/2 if I bring that to the bottom. Well, guess what this is? If I multiply these, x to the first power times x to the 1/2, I add exponents. So that's 2 over 2, so that's 3/2. So this is simply 8 over x times the square root of x. Okay, let me get rid of that so it's not in the way. And so the reason that I notice this now is that these have become like terms. So negative 4 plus 8 will give me 4, and then x square root of x minus 7 over x squared. And this is the format that my math lab has your final answer. Now there's actually another way you can work a problem like this. So it was y equals 7 plus 3x minus 8 square roots of x over x. Whenever there's only one term in the denominator, this is the only time well, I don't want to say that, but it gets more difficult. When there's only one term in the denominator, you can rewrite this as 7 over x plus 3x over x minus 8 square roots of x over x, right? Because that's easy to do when there's only one denominator. And certainly I can see that that cancels. And now I just start using my power rule, so I don't even have to use a quotient rule, because this is actually 7x to the negative 1, remember? And this piece would be minus 8 square roots of x times x to the negative 1, so we'll figure out what to do with that. And so from this point now I can take my derivative, so this will be negative 7, so let me write derivative now, negative 7x to the negative 2. I need to clean this up a little bit, so that's x to the 1/2 power times x to the negative 1, which I could write like that, which would simply be the same thing, so I'm going to add 1/2 minus 2 over 2 and get negative 1/2. So this becomes minus, let me write that over here, minus 8 to the x to the negative 1/2 power. So if I bring down, if I use the power rule and bring down the negative 1/2, that becomes positive. Half of 8 is 4x. Subtract 1 from my exponent. So I get x to the negative 3/2. And guess what? This is the same answer that we got above. 7 over x squared plus 4 over x to the 3/2 power, which once again we rewrote the 3/2 power as x to the square root of x. So this is kind of nice because if you only have one value in the denominator, you could actually break it apart like this and simply use a power rule instead of a quotient rule.